Hello friends and welcome to another tutorial on Geeks for Geeks. In this video, we are going to understand the program which helps us in counting number of nodes which have more number of children than parents in a n-ary tree. First, let us take an example. The tree is represented using agency list representation. So, for any node say U, the number of children of this node can be given as adju.size. Now, the idea is to apply BFS on the given tree, and while traversing the children of a node U, say V, we will simply check if agency list of V's size is greater than agency list of U's size. Now, let us have a look at the algorithm. Let us also have a sample tree to test our algorithm. We pass the root node, which is 1, and an agency list vector which stores the children of each node to the countNoted function. Now also, we take a count variable and initialize it to 0. Note that we will be using a queue data structure, and we push the root node into the queue. Since queue is not null, we enter the while loop and take a node which points to queue's front, so node will point to 1. Next, we pop 1 from the queue. Now, we run a for loop from 0 to size of adjacency list of 1, which is 2. Next, we take a children variable which will store the child nodes of 1. So, first, children will be 2 as 2 is the first child of 1. Now, we check if the size of adjacency list 2 is greater than size of adjacency list of 1. As size of list of 2 is 3 and size of list of 1 is 2, the if condition gets satisfied and we increment count. So, count will be 1. Next, we push children, which is 2, into the queue. Now, in the next iteration of the for loop, children will be 3, which is the next child of 1 in the list. Since 3 has only one child, its list size will be 1 and it is not greater than the size of list of 1, which is 2. So, count is not incremented and we push 3 into the queue. We come out of the for loop and continue execution with the while loop as the queue is not empty. Now, node will point to 2 and 2 will be dequeued. Now, the for loop will run thrice as list of 2 has 3 elements. Note that all the children of 2 has 0 elements in their list. So, satisfied and we enqueue children one by one into the queue. After enqueuing all the children of node 2, we come out of the for loop and continue execution with the while loop. Now, node points to 3 and 3 will be dequeued. The adjacency list of 3 has only one element, so for loop will run once and children will be 9. As the list of 9 has no elements, the if condition is not satisfied and we enqueue 9 into the queue. We continue with the while loop and one by one, we dequeue nodes from the queue. Since all nodes in the queue have no children, we don't iterate in the for loop. Finally, the queue becomes empty and we break out of the while loop and return count, which is 1. Hence, there is only one node with more number of children than parents. With this, we finish execution for this program. Now, let us have a look at the time complexity of the program. This code will run in big O of n complexity. Here, n are the number of nodes in the tree. With this, we come to an end of this tutorial. For any doubts or suggestions, please leave them in the comment section below. Thank you for watching.